In this lesson, we will learn how to work with text using the C++ string class. Let's dive into the world of C++ strings and explore how to effectively manipulate text data in your programs. Here is a simple example to get started. We include the iostream and string headers. Inside the main function, we create a string variable called greeting and assign the value hello, C++ strings. Finally, we print the string to the console. Now, let's discuss the different ways to initialize a C++ string. You can create strings using several methods. The first way is the default constructor, which creates an empty string. You can also initialize a string from a C-style string literal. Another way is to use the copy constructor, which creates a new string as a copy of an existing one. You can also create a string from a substring of another string, specifying the starting index and length. Lastly, you can create a string by repeating a character multiple times. Here's a code example. S1 is an empty string. S2 is initialized with the literal hello. S3 is a copy of S2. S4 is a substring of S2, starting at index 1 with a length of 3, resulting in L. S5 is created by repeating the character of 5 times, resulting in AAAAA. Now let's explore some basic string operations in C++. Strings have several methods that allow you to get the length of the string, check if it is empty, clear its contents, extract a substring, or append to it. Here's a code example. First, we create a string variable named text and assign it the value C++ programming. We find the length of the string using the length method and store it in the len variable, which will be 15. We check if the string is empty using the empty method and store the result in the isEmpty variable, which will be false. We extract a substring from the 4th position with a length of 11 using the substring method and store it in the subvariable, which will be programming. Finally, we append language to the text string using the += operator, resulting in C++ programming language. C++ strings provide various methods for modifying their content. These include insertion, replacement, and deletion of characters. You can insert content at a specific position, replace a portion of the string with new content, and erase characters from the string. Additionally, you can add characters at the end of the string using pushback. Strings also support manipulation operations like swapping contents with another string, resizing the string, reserving capacity to avoid reallocations, and shrinking to fit to reduce memory usage. Here is a code example. First, we initialize a string variable named str with the value hello world. We insert beautiful at position 6 using the insert method, resulting in hello beautiful world. Next, we replace beautiful with amazing using the replace method, resulting in hello amazing world. Finally, we erase amazing using the erase method, resulting in hello world. C++ strings provide several methods for searching within a string. These methods allow you to find the first or last occurrence of a substring, find the first or last match of any character from a given set, and find the first non-matching character. The find method searches for the first occurrence of a specified substring within the string. The rfind method searches for the last occurrence of a specified substring within the string. The find first of method searches for the first occurrence of any character from a specified set of characters. The find last of method searches for the last occurrence of any character from a specified set of characters. And find first not of method searches for the first character that does not match any character from a specified set of characters. Here's a code example. We initialize a string variable named text with the value, programming in C++. We use the find method to find the first occurrence of the substring. The position is stored in the variable POS, which will be 12. We then search for the substring m, starting from index 5. The position is stored in POS, which will be 7. Next, we use the rfind method to find the last occurrence of the substring m. The position is stored in POS, which will be 7. Finally, we check if the substring was found by comparing pos with string : pos. If they are equal, it means the substring was not found. C++ strings can be compared using various operators and methods to check for equality, inequality, and lexicographical order. You can use the equality equals equals and inequality not equals operators to check if two strings are equal or not equal. For lexicographical comparison, you can use the less than or equals to, greater than, and greater than or equals to operators as well as the compare method. The compare method returns a negative value if the first string is lexicographically less than the second string, a positive value if the first string is lexicographically greater than the second string, and 0 if the strings are equal. Here is a code example. First, we create three string variables, s1, s2, and s3, with the values apple, banana, and apple respectively. We use the equals equals operator to check if s1 is equal to s3, which will be true. We use the not equals operator to check if s1 is not equal to s2, which will be true. We use the less than operator to check if s1 is less than s2, which will be true because a comes before b lexicographically. Next, we use the compare method to compare s1 with s2, which will return a negative value since s1 is less than s2. We compare s2 with s1, which will return a positive value since s2 is greater than s1. Finally, we compare s1 with s3, which will return 0 since s1 is equal to s3. C++ strings can be accessed and iterated over in several ways. You can access individual characters using the square brackets operator without bounds checking, or using the at method with bounds checking. Additionally, you can access the first and last characters using the front and back methods. For iteration, you can use iterators or range base for loops to traverse the string. Here is a code example. We initialize a string variable named text with the value hello. We access the first character using the square bracket operator at index 0, and store it in the variable first, which will be h. We access the second character using the at method at index 1, and store it in the variable second, which will be e. We access the first character using the front method, and store it in the variable start, which will be h. We access the last character using the back method, and store it in the variable end, which will be o. We iterate over each character in the string using a range base for loop. In the loop, we can process each character. Alternatively, we iterate over the string using iterators. The auto keyword deduces the type of the iterator, in this case a string iterator. The asterisk it gives the character at the current iterator position. C++ provides functions for converting between string types. You can convert a C++ string to a C-style string using the C_str method, and a C-style string to a C++ string, by directly assigning it to a C++ string variable. Additionally, you can convert numbers to strings using the toString method and strings to numbers using functions like stod, stoi, and others. Here's a code example. We convert a C++ string named cppstr to a C-style string named cstr using the C_str method. Next, we convert a C-style string named cstring to a C++ string named cppstring by directly assigning it. We convert an integer named number to a string named number str, using the toString method. Finally, we convert a string named number text to a double named pi using the stod method. String streams are useful for parsing and formatting strings in C++. String streams provide input and output capabilities, allowing you to extract values from strings and build strings from multiple values. There are three main types of string streams: string stream, I string stream for input only, and O string stream for output only. String streams are particularly useful for converting between types. Here's a code example. We include the ststream header. We have a string data containing multiple values separated by spaces. We create an iString stream named ISS from the data string. We declare a string variable named name, an integer variable named age, and a double variable named height. We extract the values from the iString stream into the respective variables using the extraction operator. Next, we create an OString stream named OSS. We insert the labels and variables into the OString stream using the insertion operator. Finally, we extract the resulting string from the OString stream using the str method and store it in the result variable. Here's a complete example of how to work with strings in C++. This example covers modifying the string and finding a substring. Some best practices for working with C++ strings includes using reserve for known sizes to avoid reallocations, preferring at over square brackets when bounds checking is needed, and using string view for non-owning references to strings. Here is a complete string example. First, we include the iStream and string headers. Inside the main function, we create a string variable named message and initialize it with the value C++ strings are powerful. We replace the first 3 characters of the string with modern using the replace method. We find the position of the substring powerful using the find method. Finally, we print the modified message to the console. For performance, use reserve to allocate memory for a string when you know its size in advance. For safety, use the at method over the square brackets operator when you need bounds checking to prevent out-of-range access. In modern C++, use string view for non-owning references to strings to avoid unnecessary copying. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.